Hi, and welcome to the first of a series of videos covering all aspects of LED grow light technology. Brief introduction about myself. I'm a professional engineer. I've been involved in LED grow light technology for the last 12 years, mainly completely by accident. A friend of mine bought a LED grow light and plugged it in, it blew up, and so I got called in to fix it. Got interested in technology, spent the next 2 years building prototype lights, experimenting with different spectrums. At one point I had 6 grows going all at the same time with different spectrums over them, all clones, which you need for meaningful data, and got really interested in it. Eventually wound up quitting my job and starting a company and making LED grow lights. One of the reasons why I'm doing this series of videos is that things haven't really changed since I started, in as much as there's a huge amount of misinformation and disinformation out there. So I thought I'd do a series of videos covering every single aspect, from LEDs, power supplies, circuit boards, external optics, spectrums, types of LEDs, you name it, I want to cover it. We're even going to get some cheap Chinese LED grow lights, take them apart, see what's inside, and I'll show you how to repair them and upgrade them. So if you've got an old light stick sitting in your closet somewhere, I'll show you how to bring it back to life. Now, what I want to do with this series is something a little bit different from most other LED grow light videos or websites. And I want to start off with the very basics, and every video will involve things like experiments where I can actually show you the stuff I'm talking about, and I'm also going to include links at the end to websites like Wikipedia, both for extra study and also to prove that what I'm saying is correct. As I say, there's a lot of misinformation out there. Now, if you're interested in LED grow lighting, you've probably talked to people and gone on forums and whatever, and what you find is that people's opinions are very, very divided. Half of the people you talk to will say they're fantastic, they're amazing, would never go back to HID, to HPS, and the other half will say, no, waste of money, stay with HPS. And the funny thing is they're both actually basing their opinions on experience, and they're both right in that some of them will have had bad experiences, some will have good. Now, one of the problems is, why is this the case? People have completely different experiences with LED grow lights. Well, one problem is that companies have a tendency to exaggerate slightly on the amount of power that you need for a certain area. You'll get people saying, oh, 100 watts of LED is fine for 1 square meter. Other people will say things completely differently. And it would be great if there was some way of actually working out who's telling the truth, so you'd know how much power you genuinely need. Well, there is. And it's the basis of why LED grow lights are, or can be, vastly superior to HPS. And that is called luminous efficiency. And that's what this particular video is about. So let's go to whiteboard program on the computer over there, and I will show you what luminous efficiency is, what it means for LED grow lights, and why people have different opinions on them. So let's go take a look.
Okay, so what is luminous efficiency? Well, luminous efficiency is a measure of how efficiently a light source converts electricity into light. Whenever you put electricity into a light source, you get two things out. You get heat, which you don't want, and you get light, which is what you want. The percentage of the electricity that actually gets converted into light rather than heat is your luminous efficiency. So let's take a look at some different lighting sources and compare efficiencies. Now, starting off with the old-fashioned incandescent, that was only 2% efficient. So if you put 100 watts into a light bulb, you got 2 watts of light out. Very, very inefficient. Next up, fluorescent. Big improvement, 10% efficiency. Still not exactly what you call fantastic, but still, you put 100 watts in, you get 10 watts of light out. HPS, 20% efficiency. That's why it got used for growing, and still is. So you put 100 watts in, you get 20 watts of light out. Now that allows us to calculate how much light your 600 watt HPS, which is the sort of standard grow light, puts out. It puts out 120 watts of actual light. That's important because it allows us to calculate how much LED power we need to equal it. So red-blue LEDs, next up, big jump in efficiency. You're looking at 50% roughly. Now, I'm talking about high-quality LEDs. Your Cree, Osram, Philips, ProLight, Citizen, stuff like that. Cheaper LEDs are not nearly as efficient, and I'll show you that later. Now, you've got white LED. That's 40% roughly. It's very difficult to get an exact percentage, so that's my best guess. Now, why is it lower than red-blue LEDs? Well, the white LED is actually based on a blue LED that's then covered with what's called a downshift phosphor. This absorbs most of the blue light and then re-emits it in different colors. By mixing the different phosphors together, you can create any shade of white light that you want. Because the phosphors are not 100% efficient, it's always going to be less efficient than the blue LED by itself. The closest figure I can come up with is about 80% efficiency. So the white LED kicks out about 40 watts of light for every 100 watts that go in. Now, this is really useful if you have a red-blue lighting system using good LEDs. You're going to need about 250 watts per square meter to equal HPS. With a white LED, you're looking more at about 300 watts per square meter. So this allows you to calculate the amount of LED lights that you're going to need for a given area. So, for example, if you've got a 70 by 70 grow tent, that's approximately 1/2 of a square meter. So you're looking at about 125, 150 watts of LED power to get decent yield.
Okay, now you understand luminous efficiency and you understand how it shows that LED grow lights are basically the best choice that you can make. However, we still wind up with those unhappy people. Now, the reason for that is the fact that LEDs are not created equal. And you can buy LEDs that appear to have pretty much the same specification, especially since some of the companies selling the lower quality LEDs do have a tendency to slightly exaggerate. And unlike traditional light sources, there is a huge variation in LEDs which are sold as being the same thing. If you went out and you bought an incandescent or a fluorescent or a HPS light, you've got choices between expensive brands like Osram, Philips, etc., and cheap no-name brands from Eastern Europe, from China. And if you actually buy them, you're going to find out that surprisingly they perform pretty much the same. In fact, the longest lasting incandescent light bulb I ever had was from Eastern Europe, and it lasted over 10 years. In fact, it may still be going. I sold the house and left it in there. So there's people who are used to being able to buy whatever they want and winding up with pretty much the same performance. However, LEDs are very, very different. To give you an idea how different they are, when you create LEDs, when you make them, they're grown on a disc of material, originally synthetic sapphire, now increasingly silicon dioxide or something along those lines. They range from about 6 inches in diameter to about, which is 15 centimeters, up to 30 centimeters a foot in diameter. They're then sliced into thousands and thousands of tiny little lead chips, which wind up in your LEDs. Now, even companies like Cree that have been making LEDs for 30 years, every single chip that comes off that wafer is going to be fractionally different, and there's also going to be a difference between each wafer. It's because the quality control required to make consistent LEDs is incredibly precise. Old lighting sources, old lighting technologies, they've been around for, in most cases, around 100 years or even more in the case of incandescent. They're well understood, manufacturing processes are well understood, and they've been optimized pretty much as far as they can get. You might be surprised to know that HPS, HID, high intensity discharge lighting, and fluorescence were around in the 20s, maybe only as demonstration pieces and not actually used much, but they've been around a long time. I mean, back in the 60s and 70s, they were using, when I was in school, they had the fluorescent light tubes in the ceilings. That was the standard lighting, so it's not new technology. So LEDs are very, very different. That's why you have binning of LEDs, where they separate them into different quality levels, different brightness, voltage bins, the whole lot. So what we're going to do next is we're going to take a look at two LEDs. One is a high quality and one definitely isn't. It's a cheap Chinese LED that I just bought off of eBay. I bought about a dozen of them, and I'll probably be blowing some of them up in later videos. I got them as disposable LEDs just to make a point. So the next part is going to be the experiment. We're going to compare the output and power consumption of two 3-watt LEDs, one high quality, one low quality, and we're going to see the absolutely massive difference between them. Now let's head off to the workbench and take a look at that demonstration. And one thing I want to say before we do it, there are going to be a couple of other things going on in the video, and I want you to keep a very close eye on it and see if you can see the other two factors that I'm going to mention. And it's quite interesting and very important, so keep a very, very close eye on it and see if you can spot them. Right, let's go. Okay, now we're going to do a comparison between two LEDs. Now on the left we have a Chinese LED. This one just came out the packet, it's brand new. And over here we have a high quality LED. Now in all honesty, this one's actually an OSRAM. It doesn't matter what brand you look at, provided it's one of the top brands. They're all within a few % of each other, which isn't all that surprising. When you understand the way the industry works, they're probably using each other's chips or each other's processes that they've licensed to produce them, which is why they're all almost identical. So I've preset this to roughly 700 milliamps. I preset it because the potentiometer on here is a little bit jumpy, so it's easier if I do it beforehand. And I've also got my test meter over here because, as well as comparing the output of them, I want to take a look at how much power each one is actually drawing, because I believe that there will be quite a difference between them and it should be quite interesting, make the test more interesting. So let's switch it on and see what we get. Now, as you can clearly see, there is a massive difference. This one looks really dim compared to that one, which is actually overloading the sensor on the camera. There is no comparison. Now, if you look at this, we're just over 700 milliamps. These are both 3-watt class LEDs. And we've got a total voltage going in there of about 6.1 volts. Okay, now let's take a look and see how much each LED is taking of that 6 volts. Now here you've got, I don't know if you can see it, you're getting 3.75 volts. That's off the Chinese one. Okay, now let's go and swap the wires across, hopefully without breaking the connection. Right, now we're looking at the high quality LED, and that is drawing, I don't know if you can see that there, it's 2.2 volts. Okay, so a massive, massive difference between the two LEDs. And the Chinese light is putting out less than a quarter of the power of the quality LED, while drawing about 1.5 times as much power. So that really gets across the fact that LEDs are not all created equal. And
I don't think you can really demonstrate it better than that. So, right, let's go back and finish off the video.
Right, well, I think that was a pretty clear demonstration of the differences between high and low quality LEDs. I've got to admit, I was actually surprised by just how awful the Chinese LED was. Whoever made that really excelled themselves. Anyway, did you spot the other things that were going on in that video? Well, the first one is that the Chinese LED started off dim and got quite a lot dimmer throughout the video, and we were only talking like 2 minutes here. And the other thing was that the drive current increased at the same time. It started off, if you looked, it was drawing 669 milliamps, and yet by the end of the video the power supply was showing 749 milliamps. Now that's actually why the Chinese LED got dimmer. It was heating up and it was drawing more power. All of that increase, or 90% plus of it, was actually the Chinese LED. So as LEDs heat up, they draw more power, they become less efficient, they draw more power. Because they draw more power, they heat up more and faster, become less efficient, draw more power, and it's a vicious circle, and eventually the LED will blow up. If I'd left it probably just a couple minutes more, it would have passed the maximum current that it could draw without burning out, and it would burn out. Now, the other thing that happened was, if you looked at the voltages, I specifically read out the voltages for each LED, if you did the math, you'd find the Chinese LED was drawing 2.6 watts, roughly, and the high quality LED was drawing only 2.2 volts. Now that works out 2.6 watts for the Chinese LED and 1.54 watts for the high quality LED. Now the interesting thing about that is both of them are sold as 3 watt LEDs, and yet don't draw 3 watts. The next video is going to be about LED wattages. We're going to look at the wattages of individual LEDs, and we're going to look at the wattages of entire grow lights, and we're going to look at how both of those are specified or not specified, as the case may be. And you're going to learn something very, very interesting about power ratings in LEDs. And remember, it is important, because one thing, when you buy a 200 watt LED light, you are expecting to get a 200 watt LED light. Chances are you won't. And as we've already talked about in luminous efficiency, it's quite important to get sufficient power output for your grow area. And so the next video is going to be on how to work out what you're actually buying and what that power rating actually means. And in a lot of cases, it's going to be quite an eye-opener and quite a surprise. So please, come back, watch the next video. If you've enjoyed this video and you've learned something from it, I certainly hope you have. Please subscribe, like, and also please comment. I'd really like to know what you think of the video. I'd like to know any suggestions on how I can improve the videos, and also what you'd like to see in later videos. Okay, so goodbye from me, and thank you very much for watching the video. Happy growing.